So Ramesh, last time you showed me both the finite state graph and the finite state table for the traffic light. Can you show me the engine?
All right, so the FSM we're looking for is the traffic light FSM, right?
Yeah.
And we made a state transition graph for it, built a state transition table out of it, and then we built our C data structure out of it, which was an array of states, right?
Okay.
Here is our data structure in C.
Oh, look at that. It's
So
beautiful.
we're gonna define our state. We defined our state to have three attributes. It's a structure with three attributes: out, which is output; time, which is the dwell time; and next, which is the next states I can go in each of the current states. We defined our hash defined, so every state gets a number. So we had 4 states, and each state gets a number: 0, 1, 2, 3.
And what's that number mean?
So that number has two purposes. It uniquely identifies each state,
Yeah.
but it's going to be our index.
Ah, I see.
It's
Okay.
the index into our array.
So rather than use a state name, we're going to have an index for each state.
Yes. And by using an index, we're able to build our FSM array by referring to those indexes in this next
Got
state
it.
array.
I got it. Now, it looks to me like that C code is exactly the same as a state transition table. Is that right? Is there more or less?
There should be no more and no less. And
okay,
so we're
perfect.
saying that this transformation, these are identical.
Yes.
So there's no difference between the graph, the table, and the C data structure, and everything is captured that is in the design is captured there.
Perfect.
So now let's work on the state transition, the engine that drives this, right? So first, the main thing we need for the engine to work is we need a current state.
Ooh.
So we'll make that event 32 underscore t my current state, and we can even initialize it right at the as a global variable, or we can put it off later. For now, I'm just going to initialize it here itself. So it's going to be a go not, because that was our first state.
So the current state is that index that you just talked about.
Exactly.
See.
So the initial state is that. So now this is our main program itself. In my main program, if you put yourself in the shoes of the FSM, how do you navigate it? Well, we need to do some initialization. So we'll do some initializations. We'll initialize the clock. We're going to use systic, so we're going to initialize the systic. I'm just going to put the statement here, a comment. We'll initialize the systic. We'll initialize the I/O, my GPIO, because we have our switches and LEDs are on specific pins, so we initialize that. If there's anything else, we'll do it here. But this is where our engine is. Our engine is a while loop which never ends, because that's what an FSM is. It runs continuously.
So what do I do first?
And so in a Moore FSM, we said that the order of events is, the first event I'm going to do is we're going to produce the output, right? We'll produce output. So I'm going to put here and the output based on the current state. So how do I grab the output? Well, first thing, we're going to write to our GPIO pin. This is GPIO B.
Okay.
Because that's where our outputs are. And we're going to write it to GPIO B to our D out.
Cool.
31 underscore 0. And where do we find the output for the current state? The current state is the index. So if I do an FSM of the current state, and I grab the field of interest to me, which is out, that will do it.
Yeah, so that's going to be the 21, 22, C, or 1-4.
Exactly.
But Ramesh,
Yeah.
come on, that's not friendly.
Well, it's not friendly, so I ought to write this friendly. So let's see what a friendlier version of this would look like, right? The friendlier version of this would have been if I wrote GPIO B and do the D out. We're going to change it, but before we change it, we're going to look at what its current value
Yeah,
is.
because you want to leave the other whatever
Exactly.
bits
So
the same.
we're going to do again our GPIO B It's going to be a long statement, but we'll do it. We'll do a d out 31 underscore 0. Let's first isolate the bits we want, and
Okay.
the bits are the lower 5 bits, so we're going to do
6 bits.
6 bits, so we're going to do a 0x3f, that'll be 6 bits. And now that I have them, I can OR them with the FSM of CS
I knew you could do it.
dot out. So that'll be the friendly version. Now we have our first step done.
Okay,
So-
what do we do second?
The second step in a Moore FSM is to then dwell in that state for a certain amount of time. So we wait. And we wait so that whatever the state is responsible for, if it's producing some output, that persists for that amount of time, right? So where do I get our wait time? I'm going to get my wait time from this FSM CS. So I'm going to get the FSM CS and dot wait.
No, dot time.
Dot time.
Come on,
Yes.
Ramesh.
So we're gonna get the time from there, and we're gonna pass it to a function, and we'll pass it. We have a systic function that we're gonna write, and that systic function is gonna basically delay for in units of milliseconds.
Okay.
Right? Because that's why we made these 3000, because that's 3000 milliseconds is what we wrote it as.
Yeah, sure.
So that's 3 seconds, and so that'll be our wait.
All right,
Wait.
so that's 2. What's next?
So our next step is we want to change to a new state, but the new state is dictated by the input that we get. So we're gonna read the input,
Okay. And where did you put your input?
and the inputs in our problem were on PB7 and PB6.
Okay.
And the outputs, these were our inputs, which are our two switches or the sensors, and my outputs were on PB5 through PB0.
Got it.
Right. So now we're gonna get our input. So maybe we have a variable that we want to use called input. We could declare it here, or we could have declared it up above. So I'm gonna get a uint 32 underscore t. I'm just keeping it simple. It doesn't need to be. It's only a 4-bit, a 2-bit number, but I'll still get it. And I'm gonna call this my in, and I'm gonna get it from my GPIO B, and this is D in because I'm getting it from the input 31 underscore 0, and we're gonna just fetch these 2 bits which happen to be in. So I'm gonna isolate the 2 bits, which is gonna be 0xC0 because that's the bits of those 2, but we want it to be a 2-bit number, so we're gonna take this and we're gonna right shift it by 6 places.
Perfect. So now in input, I have a 0, 1, or 2, depending upon how many switches I've pushed.
Yes.
Oh, 0, 1, 2, or 3.
Yes. Which is basically we're taking this number, but if I just left it there, it'll be
In the wrong
It'll be in
spot.
the wrong spot. So we shifted it.
All right. So that's 3.
and
No,
I-
and what's next?
Our last step, let me just put the while loop here so I know when I'm ending. So my last step is to change state. And to change state, my state is CS. We know my state is CS. So my new CS should be, I go to my FSM, I grab the current state, I see what its next array is, and I'm going to use the index that I just figured out, which is my input, as an index into that.
So you can write code with 2 indices in the same thing? Wow.
So we're grabbing
I'm
the
confused between the 2 indices, Ramesh. Explain. You got 2 sets of brackets in there. What are they?
All right, so we're first grabbing the array location that we want, the
That's
state
the current
information.
state.
That's your current state.
And
That'll go into one of these rows depending upon what CS is. So once I get there, I need to make this journey into this array, and that I do with this dot next. And once I'm there, I need to go into
now
the
I see.
proper one. So
I see.
I do that with the in.
See.
So this is our engine, and engines are going to run continuously, and the most telling part of our finite state machine is that there are no conditional statements.
That makes it easier to debug.
No conditional statements, and all we have is 4 steps, and the 4 steps are always output, wait, get input, and change state.
All right, now I'm impatient. Can you show it to me on the board?
So let's run this code on the board. So what you see here now is our code in our Code Composer Studio, and we're just running our int main. So I initialized it up here instead of doing it here, but the same idea. I have a sysdig which actually waits for 10 milliseconds rather than the 1. So I'm going to take the time and divide it by 10.
All right.
Otherwise, it's exactly the same code, right? So now that we have it, let's run
look, you built it. Look at that.
So we have a circuit, and we have right now this initial state in which it is. So I'm going to actually run it. Let's take a look at how the circuit and the code work together. So first, let's look at our circuit. Our circuit has our LEDs. There are 6 LEDs. They represent our red, yellow, and green, and red, yellow, and green. And these are on either ends. One, we have our north-south traffic and east-west traffic. And then we have our switches, the switches which are our sensors that sense cars. So the initial state, what is the initial state, John?
It should have been go, there it is, go in. Oh, there it is.
Go north.
Go north. And so I see the north LED on.
Yes, there's our green LED on here and the red LED off there, which is our go north. So if I go through the motions of the FSM, I should transfer from one state to another state. So let's.
Can I push some buttons?
Yeah.
All right, I'm going to push.
Why don't you push the
this
westbound?
I'll just push the one button over here. Come on.
And
right. Oh, look at that.
And so the traffic has moved.
But what happens when I let go of this button?
Nothing should happen, because as far as we're concerned, 0, 0,
right,
you stay in the same state.
I'm getting it now. Can I push this one?
Yeah.
All right. Oh, it goes back.
Goes
All
back.
right, now, Ramesh, you know what I'm going to do next?
Yes.
I'm going to push them both.
Yes. And so this is the true test, I think, right? Because if the true test is if both the sensors are on, all the states have to be entered. We alternate through all the states of our finite state machine.
Sweet, cool. Good job, Ramesh.